Welcome to our next video in our Tech Talk series. Today's topic will be water applications and how do you properly utilize them with Keystone Retaining Wall products. Our products have been utilized successfully over many years in water applications, and this kind of walks you through some of the construction details necessary to utilize our products in these types of applications. Feel free to reach out to us if you have any additional questions, comments, and without further ado.
Welcome to our Keystone Water Applications Tech Talk, where we'll be discussing how to properly utilize Keystone products in water application. Keystone products have been used in a variety of ways over the years, including water applications. Some of the variety of applications we have shown here are man-made ponds, such as detention and retention ponds, or even man-made lakes and water facilities. We can be utilized in channel applications, water crossings where bridges are utilized, and even shoreline applications, natural lake or river applications for doing commercial developments or protecting shorelines. And we'll discuss a variety of these applications later on as well and show you some project examples. So early in Keystone's time, they realized that water applications was going to be a big component of how they go to market. And so in 1991, they had a university study performed to evaluate the various effects of water on Keystone products, such as high velocity, wave action, sudden drawdown, and also to help determine a mannings number that can be utilized for design work. A 10-page evaluation report was produced, and the effects were that the high velocity effects did not seem to have an effect on the Keystone retaining wall. They can withstand those high velocity flows. The wave action, there was no detectable movement observed in the wall units. There was, however, some precipitant movement of the gravel over time and a constant wave action. And there was no detectable movement for the sudden drawdown. And that was likely due to the effect that the water can move freely between the face and the surrounding soil as well. We determined our mannings number for design work, so water resources engineers can utilize that for their design and check out various other options, right? See if Keystone is a viable option when determining these these types of applications against such things as concrete or riprap, and utilize that in their designs of channels and or other types of waterways. Here we have a demonstration video of Keystone walls in action in a high velocity environment in an actual channelized flow application. I'm going to play the video here and let it run, and you can watch and I'll talk over it. You can see the storm outlet pipe here. We have a buried underground creek that was opened up for urban revitalization, and Keystone walls were utilized to kind of channelize the flow in this new park that has been opened up. We have 1,200 lineal feet of Keystone Country Manor that went in on this job. The design, we incorporated the things that we talked about in this design for this particular application, and the wall is still there performing well every day. This was a over 100-year storm event that happened roughly a year after the walls were installed. You can see they have some downward dissipators or downward flow to help try to control the flow. The bottom of this channel was actually ended up being concrete lined to help protect everything, which was a good design feature to have in this particular application. Let's talk a little bit about actual product recommendations, certain installation aspects. Number one, for most water applications, it is recommended that we utilize a 4,000 psi block versus a normal 3,000 psi block. We are in a more aggressive environment, and so we want to make sure that the block will be able to withstand over time, and having a higher compressive strength unit will aid in against those types of effects on the unit. Freeze-thaw durable units are recommended in those areas where rapid freeze-thaw can occur, and especially ones that occur day in and day out, right? So where the units are going to be exposed to freezing, rapid freezing and thawing, freezing overnight, thawing during the day, those types of things. We want to make sure that we have a unit that is able to withstand those effects as well. So we're going to make sure that our units, is recommended that our units comply with ASTM 1372 and ASTM C 1262. Construction detailing is very important for water applications. So I'm going to turn on my highlighter here so we can talk a little bit about some things and walk you through. When we start, we want to obviously start at the base of the leveling pad. And in the designer is going to call out a normal high water level and a normal water level and a high water level. We always want to be 1 foot above the high water level, whether it's 100-year. Typically, you have to design to the 100-year level. So we're going to create a free draining zone of material, typically between 3/4 inch to 3/8 inch clean crushed stone, less than 5% fine. So an open graded aggregate, right, has a lot of angularity to it, must be crushed stone. And the key with this is that it's all wrapped in filter fabric all the way around. You're going to have many zones of filter fabric. The filter fabric is key to prevent those fine particles from washing into it. We need to keep this zone of material free draining and allow for the free movement of water between the water application out here and the surrounding soil subgrade. If we don't have this free draining aggregate, we're not going to withstand that sudden drawdown. We're going to get hydrostatic pressure built up behind the wall. So we want to keep this as a singular crushed stone aggregate. The filter fabric is the key element here as well, especially as well as the leveling pad, which we're going to talk a little bit about here. We're going to have a fabric that's wrapped and protected the toe and base of the leveling pad. The leveling pad could be gravel, must be wrapped in filter fabric, or concrete. And if it's concrete, we don't necessarily need to have the fabric, but we need to have the fabric that will come and wrap along the face with erosion protection. And finally, we're going to have our final wrap up here to keep our free draining material or drainage zone aggregate, as we've shown in previous tech talks, for our walls. This is more of a standard application, but we want to continue that fabric wrap all the way to the top of the wall, just in our free draining zone behind the wall there. Leveling pad material. So we can do either a gravel or concrete leveling pad. The gravel must be wrapped in filter fabric. As you can see here, these guys have actually utilized a crushed stone. They just kept the 3/4 inch to 3/8 inch crushed stone as part of the leveling pad. They got their fabric here and fabric back, and they're going to wrap that back up in here before they get to their next zone of material or their first layer of reinforcement. It can be a concrete leveling pad. You might find that it's a little bit easier in water applications, or in certain applications where you want to protect against additional erosion or potential movement and just quick setting. Just get the concrete leveling pad in and go, because you need to work a little bit quicker. Is another application where you might consider using a low strength unreinforced concrete leveling pad. Some additional details that we'll have to consider in a lot of water applications is pipe outlets. And we did discuss this previously in our tech talk on water drainage applications. And where we have pipe outlets, we want to put in for 2-foot diameter pipes or larger. We're going to likely use a concrete headwall that matches the block coursing. And you can see here where we're matching horizontal coursing and vertical coursing in the wall. And we're cutting to half units, essentially. We're going to cut control joints up the wall so that it, because we're implementing sort of a rigid structure here, we want this side of the wall to act more independently on either side of the head wall. And we have our units above and below here as shown in the cross section. Here's the application for just checking out this is a wall sitting outside of a drainage channel with a storm pipe coming out through the face. And here you'll have your saw cuts up this part of the wall and this part of the wall. And this is actually an exaggerated head wall, but it's good. They match the coursing of the block. And they put in kind of a more elaborate head wall to make sure that they were covered. This likely actually goes below ground a little ways further than the wall just to kind of protect it from erosion. You can see all the rip-rap erosion protection here. The wall has erosion protection as well. So there are many different types of water applications that our Keystone products can be utilized, from this concrete box culvert application where it's a control type structure where the head wall's here. You can see the weir wall out in front, to a larger drainage type structure channel application. This happens to be a flash flood wash control diversion channel in Arizona. So in Arizona, they get a lot of precipitation very quickly, and that's during their rainy season, if you can call it their rainy season. But where you get a large amount of water, it comes down, it flashes into these areas, and they want to be able to control it. Well, these walls happen to be utilized in that particular application to help control the flow of water to a specific area, and to prevent further damage elsewhere for a development that was going in. We're a great application for culverts, where we can be utilized in culvert application here. Here's for a creek. They always size the culvert for the 100-year event. We can be utilized in these applications here, inlet and outlet side, where they're protecting the wall with erosion here. You can see the curve follows the curve of the stream. We got our control joints cut at the footing there to go over this, so we have a sort of a control joint to act, so these can act as an independent wall. To our retention and detention applications, here we have a Keystone wall that was utilized for a commercial site development. We have our filter fabric wrap coming up to the top. You can see here we have pipes that come up to the normal water elevation all the way around the wall. The water may penetrate all the way to the top of the wall, but we have our free draining aggregate all the way to the top. And then we can see in the inset picture, so you can see how the filter fabric comes up behind the design reinforcement length, and it's going to get wrapped over, so that entire reinforced zone for this particular detention pond wall is wrapped in filter fabric to protect everything. And the geogrid reinforcement design is designed to accommodate the water portion. If it's inundated with water, the designers are going to check for buoyancy in the design, make sure that when it's in water that it does have the capacity to withstand the extra forces that are involved. Here we have our lake or river application where our wall is sort of a border wall protecting the site. And the key thing when you do a lot of these is we must protect the toe of these walls against erosion, right? If it's a lake or river, sometimes you have water fluctuation. We want to make sure that the toe of the wall, number one, is buried deep enough against scour and erosion protection. And then number two, we got to protect that surface. So we're going to put in some type of filter fabric at the face to kind of protect that surrounding subgrade. We're going to put in our wave action material or riprap or boulders or some other type of material to protect that, or even hard armor like a concrete revetment system. Sort of a unique water application one here done in the 90s was this Mount Laurel Dam in Alabama to create a reservoir, a man-made recreational lake. You can see here from Google Earth, you can go and check it out. You can see the dam portion of the wall here with the backside of soil, earth, and dam, and then the water holding it up. Here's a view from the front of it. You can see the wall sitting in place with the overflow structure cascading over the top. They have their protection here against the wall, and the water holding the earthen dam in place with soil reinforcement extending back here. Kind of a great little project, a unique application for Keystone Walls, and to be utilized in this particular way was an interesting case study for us as well. So thank you for your time and checking out our water applications tech talk, and keep tuned in for more tech talks as we continue our series, and hopefully you find these beneficial. As usual, find more at keystonewalls.com, our applications, all kinds of other case studies. Thanks a lot.